Hello friends, welcome to our channel Knowledge Amplifier, and in this particular video I am going to discuss some concept related to vector space and 3D geometry, whatever you have already studied in your school days. Okay, just this particular concept you need to understand before moving ahead with the derivation of support vector machine. Okay, so that I am discussing this part. Okay, because some concepts it will be difficult for you if you just have not touched with this particular vector space. Okay, so that's why I am just giving one mathematical intuition related to this. So what I have done, I have taken here 3D space xyz direction, and this pink type line, for this the vector equation we need to determine. Okay, straight line equation, right? What we have one particular point A on this particular line for which the position vector we know. Okay, you remember we have studied in physics the position vector xi cap plus yj cap plus zk cap. For one particular point we can say x1 I cap plus y1 j cap plus z1 k cap, like that. Okay, so for this particular point the position vector is a1. Okay, this vector what we know, and we know one vector b, okay, which is parallel to the line for which the equation we need to determine. Okay, this b vector also we know, which is basically one vector we can say parallel to this particular line. Okay, b vector, this particular vector, you can see that this is parallel to this particular line. Okay, and we are taking one random point p which is on our straight line. Okay, and if we able to determine the position vector for p, okay, that will be basically nothing but straight line which is passing through a given point A and parallel to a given vector B. Okay, if we just, our intention is we need to calculate the expression for this r vector, position vector for P, point P, which is an arbitrary point on our this straight line. Okay, now what you can do, apply this simply vector formula. R vector is nothing but, which is basically OP vector, is nothing but OA vector plus AP vector we can say, right? That's what I have written here. Okay, from the law of triangle. Okay, right? Now what is AP vector? Okay, that is from A to P. What is the value? Okay, direction and magnitude. See, this particular part is on the line itself, which is basically parallel to our B vector. Okay, so what is the unit vector parallel to B vector? We can say B vector by mod of B vector, and that particular same direction is our AP vector also. So multiplied by some magnitude, if you do, you will be getting the AP vector. So AP vector can be written like this: m, one particular constant which is basically indicating the magnitude part, multiplied by B vector by mod of B vector, that is direction as same. So we can say m by mod of B vector as lambda, and we can say AP vector is equal to lambda B vector, right? So this particular AP vector can be represented as B vector multiplied by some constant. Okay, so now replace that. What is OA vector? OA vector is this small a vector, which is the position vector for the point A, and this AP vector is basically lambda B vector. Replace that, you will be getting R vector is equal to A vector plus lambda B vector. This is the equation for this straight line, okay, which is passing through a point A for which the position vector is small a vector and parallel to B vector. Okay, so this is the equation. Now if you want to get the Cartesian form, so simple R vector is equal to xi cap plus yj cap plus zk cap, where x, y, z can take any value. A vector is equal to the position vector of this particular point A, okay, which is certain value, so that to indicate that I have taken constant x1 I cap plus y1 j cap plus z1 k cap, and B vector, which is basically parallel to our this particular straight line, one vector. Okay, suppose I am taking Vx I cap plus Vy j cap plus Vz k cap, right? So here also these are constant, these coefficients. So if you just replace all the value of R vector, A vector, B vector in this particular equation, you will be getting x I cap plus y j cap plus z k cap is equal to x1 I cap plus y1 j cap plus z1 k cap plus lambda into Vx I cap plus Vy j cap plus Vz k cap, right? Now just equate the magnitude for I vector, J vector and K vector, you will be getting this equation: x equal to x1 plus lambda Vx, y equal to y1 plus lambda Vy, and z equal to z1 plus lambda Vz. So lambda term is common in all the equation. So if you just equate with respect to lambda, you will be getting this particular equation. Okay, x minus x1 by vx equal to y minus y1 by vy equal to z minus z1 by vz. This is very popular equation, and all this equal to basically lambda. Okay, so this is the Cartesian form for a line which is passing through a point for which the position vector is a vector, which is nothing but x1 i cap plus y1 j cap plus z1 k cap, and that particular line is parallel to a vector for which the value is vx I cap plus vy j cap plus vz k cap, right? So this Cartesian form you just remember. So suppose I am asking you what is the direction of our this particular line. Okay, direction is obviously will be same like b vector direction, and the value part if you just consider, you can say that the direction is same like vx I cap plus vy j cap plus vz k cap, right? So basically these coefficients, these constant values are important because these are basically representing the direction for our original line also. Okay, so I hope this particular concept or recall session of the mathematics concept whatever we have studied in vector space in our school level mathematics is clear to you. If you have any doubt you can ask in the comment section. This is all for this video. In my next upcoming videos I will discuss some more concepts, and then I will relate this concept with our SVM derivation. Okay, thank you for watching.